In this video we are going to study about the laws of refraction. In previous class already we have discussed about the refraction. Today we will discuss about the laws of the refraction. So first law says that the incident ray, the refracted ray and the normal all lie on the same plane. Means here if this is our interface and this is our normal, whenever the light ray is incident on this interface, then what happens means instead of going in this direction, the light ray will change its direction. It will bends, the light ray will bend and it will travel in this direction. So this is our incident ray and this is our refracted ray, and this angle we'll call it as angle of incidence, and this angle is the angle of refraction. In reflection, what we have studied, whenever light ray strikes on any surface, it will reflect back, and here if we draw the normal, then this angle and this angle both will be equal. Angle I is equals to angle R, and this incident ray and this reflected ray and this normal all are on the same medium. Means in same medium only they will pass. But here this is the medium 1 and this is the medium 2, both are having different refractive index here. In this case only one medium, means only one refractive index will be there. Means here only in one medium the light ray is traveling. It is in this also light ray is bending, but it is bending in only one medium. But here the two mediums are changed. Means here light ray is traveling from one medium to another medium. When light ray travels from one medium to another medium, its velocity will be different. Here it is traveling with v1 velocity, and here this refracted ray is traveling with velocity v2. So because of that change in velocity, light will bend. This phenomenon already we have studied. Now we will study about the laws, on what basis this refraction is taking place. So first law says that incident ray, this incident ray, this refracted ray and this normal all will be lying on the same plane. Means if the incident ray is like this, means the refracted ray will not come like this. It will go, it will be on the same plane it will be passing. So this is the first law of the refraction. Second law says that and sin I by sin r is equals to constant. In reflection, what we have studied, angle of incidence is equals to angle of reflection, but here in this case angle of incidence is not equals to angle of refraction. Because of change in velocity, light ray has bent. Because of this bending, the angle of refraction has been reduced. Means here these two angles are not equal. Here we can easily do the calculation. Means if the angle of incidence is 30 degree, then we will compulsory this reflection will be angle will be always 30 degree. This we know in case of reflection. But here how to calculate? Means if we are changing this angle of incidence, then how this angle of refraction will be changing. So to calculate that, means how these two values are dependent, whether they are inversely proportional, whether they are directly proportional, means how to calculate, means if the I value is changing, how the R is changing. So to do that calculation, we have taken sin I by sin R value is always will get constant for a pair of medium. For a pair of medium, means here if you take any medium, air medium and here water medium, if this medium is fixed, suppose if this air and this water, if you are not changing these two medium, if you are changing this angle, then this angle will also be different. But if you take the ratio of these two, then you always will get the constant value, and this value changes if these two mediums are changed. Means if you take air to glass or air to water, then this constant value will be different. If you take two mediums constant, then this value will be always constant. This is the second law. Sin I by sin R value always you will get the constant value. Suppose if you take this angle 30 to 60 degree, 60 to again any degree if you take, then this refraction will also be different, and if you take the ratio again you will get the constant value, and this constant we will call it as the refractive index. So this relation can be written as sin I by sin R is equals to refractive index. Refractive index of which medium? Here two mediums are there. Here this is the first medium, this is second medium, both are having different refractive index. So here sin I by sin r value is equals to refractive index of second medium with respect to first medium. So this value can be written as refractive index of second medium divided by refractive index of first medium. And next after that, this relation can be written as mu1 sin I equals to cross multiplication mu2 sin r. So this expression is called as the Snell's law of refraction. Snell's law of refraction. Sin I by sin I value is equals to constant. This is also called as the Snell's law. Sin I by sin r value always you will get a constant for any pair of medium. So this relation and this relation both are called as the Snell's law of the refraction. So using this relation we can calculate the refractive index of first medium or the second medium. Next after see here, refractive index of second medium with respect to first medium is equals to reciprocal of refractive index of first medium with respect to second medium. This also you can use, this relation also you can use in the numericals because both are reverse. Reverse is always equal. And next after that, see here, whenever the light rays traveling from one medium to another medium, velocity is changing. Here this velocity is v1 and here velocity is v2. And next after that, if you see the relation, velocity is equals to frequency into wavelength. So in this case, this velocity and this wavelength both are dependent on the medium. Dependent on medium, and this frequency is dependent on source of light. Means here if this is having velocity v1 means here frequency will be f, and here also the frequency will be f. Frequency will not change because the light source has not changed, only the medium has been changed, means wavelength will be changed. Here it is lambda 1 and here it is lambda 2. So now we can write it as sin I by sin r is equals to mu2 refractive index of second with respect to first means mu2 by mu1, and this is equals to v1 by v2. Why we are writing v1 by v2 means refractive index is equals to c by v. Here c is the velocity of light in the air or the vacuum medium. So this value will be always remains constant. So if it is constant means refractive index is inversely proportional to velocity. So for that reason here mu2 means here inverse relation, mu2 by mu1 means v1 by v2. So now this relation, see here, sin I by sin r equals to mu2 by mu1 is equals to v1 by v2. In place of v1 what we can write, v1 is means f lambda 1, v1 is equals to f lambda 1, v2 is equals to f lambda 2. Because when velocity changes, wavelength, these two quantities are changing, frequency remains unchanged whenever light travels from one medium to another medium. So in place of v1 we will write f lambda 1, and here we will write f lambda 2. F frequency both are same, so it will be cancelled. So this relation you have to remember to compare with any two values. If we are doing comparison of wavelength with the refractive index, then also we can take this relation. If we are doing calculation with velocity and refractive index, then also we can use this relation. So this relation you have to remember. Next after that we will study about the absolute refractive index and relative refractive index. absolute refractive index mu. Absolute refractive index means whenever we are doing calculation, whenever we are calculating this refractive index of any medium in comparison with the air medium, then it is called as absolute refractive index. For example, here I want to do the calculation of refractive index of water. Then if I compare this refractive index with air, then it is called as the absolute refractive index, and this can be written as refractive index of water divided by refractive index of air, and this can be written as velocity of light in air divided by velocity of light in the water medium. In this way we can do the calculation, and this value is called as the absolute refractive index. Any medium, here you can take any medium, water, glass, diamond, any medium if you take, and if you compare that medium with the air, then only it is called as the absolute refractive index. Air is considered as the standard medium. Why air is considered as standard medium means in air light travels at a maximum speed, that is c is equals to how much, 3 into 10 to the power of 8 meter per second. So this is the maximum speed of light, and this maximum speed we will get only in the air medium. In other medium, air, for example glass, water, if you take any other medium, in that light travels lesser than this speed. So air is considered as the standard medium. So whenever we are doing comparison with the air medium, then it is called as absolute refractive index. Next is the relative refractive index. Relative refractive index mu. Here refractive index of water is calculated with respect to glass. Now here also I am doing the calculation of refractive index of water, but here with which medium we are comparing means glass medium we are comparing. Then it is called as relative refractive index, and it is written as refractive index of water divided by refractive index of glass, and this is equals to velocity of light in glass divided by velocity of light in the water medium. In this way we can write. See the relation. Here refractive index of water is compared with the glass. Any medium you can compare except the air medium. If except air medium, if you compare with any medium, then it is called as relative refractive index. If you are comparing the medium with the air, any medium with air medium, then it is called as absolute refractive index. So this is the difference between absolute and relative. Whenever they have given absolute refractive index of water, absolute refractive index of water means they have compared the velocity of light in the water medium with respect to air medium. If they have given relative refractive index, then you have to see with what they have compared, with water, glass or the air, means except air. If we are comparing, then it is the relative. If we are comparing with air, then it is called as the absolute refractive index. So this is all about the laws of refraction and the absolute refractive index and the relative refractive index, and this relation is important to do the numericals. And this one, mu1 sin I is equals to mu2 sin R, this is called as the Snell's law of the refraction. This is all about the laws of refraction, and in next class we will study about the normal means lateral shift and the normal shift.